Welcome to this strategic briefing on the intersection of swarm robotics and post-quantum security. We will explore how to secure the future of decentralized operations through an autonomous swarm. The power of the swarm lies in decentralized collaboration, drawing inspiration from nature. Unlike centralized control with a single point of failure, a decentralized swarm is robust and adaptive. Autonomous swarms are in production today. For example, at the BMW Group factory, a swarm of 27 autonomous mobile robots manages load handling. This results in moving over 2,600 tons of material weekly. The applications of swarm robotics are expanding beyond the factory floor. They include disaster response, logistics, advanced manufacturing, and agricultural monitoring. This showcases their versatility in diverse environments. The foundation of swarm collaboration is cryptographic trust. The constant, high-speed exchange of data relies on millions of digital handshakes secured by public key cryptography. However, this foundation has a known expiration date. The quantum threat will shatter today's cryptographic standards. Quantum computers use qubits and algorithms like Shor's to break current encryption, making protocols like RSA and ECC obsolete. The threat is active now through a harvest now, decrypt later strategy. Adversaries are intercepting and storing encrypted data today, betting on a future fault-tolerant quantum computer to decrypt this data archive. The risk window is open. The defense is post-quantum cryptography, or PQC. PQC algorithms are resistant to Shor's algorithm, relying on harder mathematical problems like those used in lattice-based and hash-based cryptography. NIST has finalized new standards for key establishment and digital signatures. PQC is viable, even in low-latency environments like 5G networks, which share constraints with swarm robotics. Performance data shows minimal CPU usage and low latency for modern PQC algorithms like Kyber and Falcon. They are suitable for real-time control. A strategic migration to PQC requires a managed process. This 5-point framework outlines the critical steps to achieve quantum readiness across your autonomous systems. Step 1 is to start with visibility and crypto agility. You can't migrate what you can't see. A cryptographic inventory is essential, as 45% of firms have suffered production downtime due to unknown certificates. Crypto agility allows for algorithm swaps with minimal downtime. The clock is ticking for global migration. Regulatory timelines are now in effect, requiring immediate action in the US, EU, and UK. The transition to PQC is moving from research to regulatory reality. PQC migration is a risk management strategy, offering a clear return on investment. Nearly half of security leaders pursue PQC to reduce cyber insurance costs. Avoidance of future breach costs, reduced insurance premiums, and compliance drive the ROI. Your first 12 months should focus on an actionable plan. This involves achieving visibility, proving the technology through a pilot, spreading the wins by replacing expiring certificates, and retiring weak links. The swarm's potential is unlocked by trust. Securing this cryptographic trust against the quantum threat is the critical path to realizing the future of intelligent, autonomous operations. Start building your quantum-safe foundation today.